Okay, Assalamualaikum warahmatullahi wabarakatuh, and how are you? Today I'm going to continue our third class, third lecture class. Actually, the first and then the second class still use asynchronous. It means you use my recording to learn the subject. And for today class also I still use asynchronous because I heard from the PSTP penyelaras we need to also consider the students' conditions. You know, if you have a good internet connection, yeah, unlimited is good, no problem for you. But some of our students, your plan is had a limited internet connection. So better I try to make this asynchronous and make a discussion, for example, later, yeah, for 10 or 20 minutes for discussion, you synchronize, but that's one is later. All right, let's we start. And today class is about forecasting. Before we learn about productivity, right? Okay, forecasting. For today, the material will be like this. Sorry. Okay, the outline of this presentation is introduction, pattern of demand, forecasting, technique, forecast errors. Yeah. As you know, as we are engineering, you cannot be like tok bohong. Yeah. Forecast is like predicting for the future. Yeah. We cannot be like this, predict without data, just assumption. You just okay. We just consider based on my experience, based on experience. This is still not good. You not to support your decisions or forecasting with data. Yeah. So as industrial engineering, you need to predict or forecast the features conditions in this productions or like demand from the customer. We need to predict, right? So we need to be confident data, yeah, based on your previous data, we can make decisions what should we get for our, for example, like production and demand and so forth. Yeah. Okay, forecasting actually the sorry, forecasting is a process of predicting the picture. It is involved historical data that I told you before and projecting them into the future with the mathematical model or intuitive prediction. And forecasting helps to determine scheduling and acquiring resources. So with the forecasting, you can be more precise, precisely to identify predicting the capacity of production, for example, yeah, the demand, yeah, for scheduling. This is very helpful for you as an industrial engineer. When you be interview, when you want to looking for a job, what is your expertise? I am expert in forecasting. It's very good. They like the job for forecasting, yeah, because it can make very important for the industry to reduce the cost if the the forecasting is correct. All right. So also accurate forecast lead to increase customer satisfaction, reduce customer response time, and use capacity accurately. Okay. Okay. For forecasting, the application includes finance and accounting, yeah, such as a project cash flow, capital requirement, and new product or process cost estimate, human resources, yeah, marketing, operations, product service, and design. This is normally used for forecasting, yeah, forecasting technique. Okay, there are 6 basic steps for forecasting. First is to determine purpose of the forecasting, and then second, you need to establish time horizon. Yeah, how long you want to predict, 1 year, 2 year, and so forth. Select forecast techniques. Okay, later I will explain. There are several forecast technique. Yeah, gather and analyze relevant data, make the forecast, and the last is monitor the forecast. Yeah. So pattern of demand. Time series repeats observations of demand for a service or product in their order of occurrence. There are 5 basic patterns of demand. First, trend, seasonal, cyclical, and random. This is type of the pattern demand. You can see based on the time and quantity, the horizontals mean the pattern is like this. Yeah? It's almost the same. And the trends mean the demands increase slowly. Yeah. And then the seasonal uh, data consistently show peaks and valleys. Okay, this is something like this, yeah, and stable and increase within 1 year, low and cyclical data relevant gradual increase and decrease over extended period of time. So sometimes in the first years decrease, and then the third and then the fourth years increase, and this is a kind of cyclical. Okay, forecasting technique. There are 2 kind of forecasting technique. Okay, first is what to be. We should ask the question what to forecast. Easiest to forecast total demand than derive individual service or product forecast. Okay, and then the second, what type of forecast technique involve trade-off between forecast accuracy, time, and cost. So this two is important when you want to do forecasting. Yeah? Later I will give you some example of the calculations for forecasting. Okay, 2 general approach in forecasting. First is qualitative forecast that incorporate factors such as a decision maker judgment, opinion, and experience. Yeah, and then the second is quantitative forecast that employ one and more mathematical model that rely on historical data to forecast future demand. Qualitative is depend on your experience. Yeah, normally this based on the trending. I mean the trending of demand, for example, the situation is like this, and then the second one is like this, and then the normally decision maker already know this trend, so it's called as a qualitative approach. Sorry, qualitative approach. It's a bit problem. Yeah, I have ulcer. Sorry. And the quantitative forecast that employ one or more mathematical model that rely on historical data to forecast future demand. Right? All right. Demand forecast applications. Okay. Application forecast quantity, and then time horizon. There are 3 kinds of time horizon: short term, medium term, long term. For forecast quantity, individual service or product. For short term, yeah. For medium term, total sales, group or families or of service or product. And the long term is total sale. Okay, decision area is, for example, like inventory, management, final assembly, scheduling, yeah, workforce, scheduling, MPS, yeah, and forecasting techniques, time series casual judgment, and casual judgment. short term, medium term, and long term, right? This is demand for forecast application. Okay, we continue to quantitative method. Okay, quantitative method should be considered time series. This is like knife for forecast. The second is simple moving average, weight moving average, exponential smoothing. Okay, the qualitative methods, Casual's model, this is like a linear regression analysis. Okay, this is you can get a better understanding when you see the example. Yeah. Okay, this is time series. NAV forecast for the next period equal the demand for current period. For example, like this handphone dealer forecast weekly new handphone sales. Okay, in the period 1 until period 4, the demand is 30, yeah, 30 until 35. So the NAV method. So this one is we give the judgment based on the the three the three forecast the next for the period for the current period. So we just move these three period 1, 2, 3 become our predictions. I mean the forecasting, yeah? 2, 3, 4, right? Qualitative method time series simply a simple moving average used to estimate average of demand and remove effect of random fluctuation. So for example, like this is specifically the forecast of period T plus 1 can be calculated like this. Okay, you can see this formula. Okay, dt actual demand in period T and total number period operate in average, and f plus 1 is forecast for period T plus 1. Okay, this is example. Okay, example, see clearly, please see this example. Okay, example, moving average. Compute a 4-week moving average forecast for the arrival of restaurant customer in week 5. The number of arrival for the past 4 weeks were, okay, this is the data, week 1 until week 4. The customer arrival is 40, 50, 46, 48, 60, 52. Okay. If the actual number of the customer arrivals in week 5 is 54, what is the forecast for the week 6? Okay. Okay, we need to predict the we need to forecast the in the week 6 what is the customer arrival. Okay, based on the formula that I give to you. So the moving average forecast at the end of week 4 is we just add, okay, add the total number and the average of week 1 until week 4. Okay, we just make the average, so the demand for week 5, I mean, yes, week 5 is 49, right? Okay, the forecast for week 6 require the actual arrival from weeks 2 through 5. The 4 most recent week of data is, so we just get collect the data from the week 2, yeah, week 2 until week 5, yeah, week 2 until week 5, starting from 46, 48, 52. Okay, and the real data is 5, and then the week 5. Week 5 is, see, this is 2025. So 25, sorry, 54. This one is 44, yeah, 54, 54, and you put this 54 in here, and you divide it by 4. So in the F6, in the week 6, demand is 50. All right. This is the qualitative method time series. Okay. And then next, weighting moving average. Each historical demand in the average has its own weight. The sum weight equals to 1. Okay, this is the example. Weight take moving average. The since car was is a place where customer can watch their car. The manager must forecast the demand for customers so that can locate the worker. Recently, the demand has been as follow. Okay, day one until day three, yeah. Day one until day three, sorry. The total customers for the washing car washing is like this. The day, the three, four, five. Focus in day four using the with other method, you see, with n recovery and the weight is the p0 with the p plus and okay, so how to answer so the three five uh, zero 0.2 divided by 3. Okay, the total result 0.7 or the 5 So, why should we one simple one? Simple of times demand more weight than earlier demands requires 3 items. Last period forecast demand for this period, and the third is smoothing parameter alpha everything and 1. Okay, this formula I will give you the example and you can read this one, yeah, formula. This is the example. Right. Wait. What is the difference? A minute, yeah. Wait a minute. Okay, we continue, yeah. Continue. Okay, this one you can read it. Formula. This is the example. Example exponential smoothing forecasting method. We consider the customer arrival data below. Is now the end of week 4 using alpha 0.1. Calculate exponential smoothing forecast for week 5. So based on this data, please calculate in week 5. Okay, the exponential smoothing methods require an initial forecast. Initial forecast. Suppose that we take the demand data for the first 3 weeks and the average of them. Obtaining, okay, the third data is 500, 560, 480 divided the sum of this one, the third data divided by 3, and the result is 480. This is as an initial forecast, right? To obtain the forecast for week 5, we using exponential smoothing with alpha 0.1. We calculate the average at the end of week 4 as, for example here, okay, in week 4, okay, this one is uh, 420, right? And plus the 480 multiplied by 0.9. Okay, you will get the result of F5 or week 5 customer arrival is 484. Thus, the forecast for week 5 will be 480 for customers. If the actual demand for week 5 prove to be 520. Okay, this one is prediction, yeah. This one is prediction, but this one is the real one, yeah. The real data. Okay, 502. The new forecast for week 6 would be, okay, same like before. We yeah, okay, 0.1 multiplied by data 502, yeah, plus 0.9 multiplied by 484, 484, and the result will be 485.8 or 486 customers. All right. Okay, you click it and pause it. If you want to replay it, just replay it. How to get this the result, right? Forecast error. Okay, forecast must always contain of error because this one is predictions. Forecasting is not always get the actual result. Sometimes has errors. Yeah, not sometimes, always has content of error. Bias error result the consistent mistake. Yeah, and then the random errors, unpredictable factor that cause forecast to deviate from actual demand. All right, let's see. Forecast error, difference between forecast error and actual demand for a given period. Okay, ET is error at the time, yeah. A the average time, actual time, and minus F is the forecast in the T period. For example, like this, no, this is still formulation, yeah. Cumulative sum of forecast error, CFE, sigma E equal with sigma error, ya. Cumulative sums forecast error, ya, atau we call it CFE is equal with it the sum of error, ya. Mean square error MSE and mean absolute deviations MET. MSE is equal with sigma E in the in the time specific time. Okay, this is standard deviation. Standard deviation is equal with a square root of this one. And you can read this, yeah, and we go to the example, right? Three type of forecast error: mean absolute percent error, MAP, MEPE, relates the forecast error to the value of demand. Okay, this is the equation. We go to the example. Actually, if you have this book, okay, you can read again in the book. Yeah, in this book has the flow how to get one. Example: calculate forecast error measure. The following tables the actual sales of table for a furniture manufacturer and the forecast made for each of the last month. Calculate CFE, MSE, standard deviation, MED, MEP for this product. Yeah. Okay, this is the data. Yeah, data. All right, and uh, the demand forecast until month 8. Yeah. Um, we can see this historical data and we need to calculate CFE here, CFE, MSE, standard deviation, MED, MEP. That's like I explained before. The what is it? Mean square error, standard deviation, mean absolute deviation. Yeah. And MP is mean absolute percent error. Okay, this is the answer. This is the answer. Okay, you can see this one. Yeah, the data is this until 8, right? And the error is, okay, see the demand is 200. The forecast is 225. So error is 20 minus 25. Error square, you just square this one. Yeah, absolute error just you what's that we call, you square this result. Yeah, you square this error and you get this result, and you can also calculate the ET per digit. Yeah, you can calculate this one. Okay, based on the equation, right? And then you will get this kind of data. Okay, you can post this, right? I already try to calculate all this data using Excel. Yeah. So let me share you my Excel. Okay, I try to calculate the data, all the data. Okay, and then the result is the same with the book. Yeah. You can see the result is 10%. Sorry, the result is 10%. Okay, cumulative forecast error is minus 15. Minus 15. It means that ACFE of minus 15 indicates that the forecast has a slight tendency to overestimate demand. Yeah, the MSE or the deviation and MED statistic provide measure of forecast error variability. MED of 24.4, yeah, means that the average forecast error was 24.5 unit in absolute value. The real value is 24.4 error, the total unit. The value of 27, okay, the value is 27.4, indicates that the sample distribution of forecast error has a standard deviation 27.4 unit. MEP of 10.2%. This one 10.1.3% or 10.2% implies that on the average the forecast error was about 10% of the actual demand. Okay, these measures become reliable as the number of period of data increase, right? So this is you need to read the example in this book, yeah, based on our that anyone who has no book just waiting for your purchasing, and here has a several example for forecasting, right? And with the answer and also the tutorial for forecasting question, right? Okay. The main idea of forecasting is you need to understand that the forecasting need the previous data, not not just only by estimations experience, but also you need to see the data. Right? Okay, thank you very much for this class. Maybe later we can more detail understand for this material in the tutorial. All right, and also in the lab. Thank you very much, and assalamualaikum warahmatullahi wabarakatuh.